rank each of these molecules based upon the number of dots each one has. Let's dissect what they're asking. When I say dots, I mean the lone pair electrons owned by individual atoms. For example, this chlorine has 6 lone pair electrons. This is completely separate from sticks, which are the bonded electrons shared between atoms. It's clear the molecules we have don't show any dots, and that's because they're written in bond line form. So let's convert each of them into Lewis structures, because doing so, as we see up here, reveals all of the atoms, sticks, and dots. If we look at this molecule up here, the ends and the bends are carbons, and they may or may not have hydrogens directly attached to it. Similarly, each of the ends and bends of our molecule of interest are carbons. So there's 1 carbon for this molecule, 3 carbons for this molecule, and 5 carbons for the last one. By nature of its properties, each atom of carbon will form exactly 4 bonds, but it's clear that from looking at this diagram, none of these carbons appear to have 4 bonds. And broadly speaking, that goes back to the fact that a bond line structure is a summary model. It doesn't illustrate all the features of a molecule. Hydrogens are in fact going to make up the difference. So if this carbon has a total of 4 bonds and we see one of them, it has 3 hydrogens for this carbon. We use this equation right here to determine the number of hydrogens owned by an individual carbon. The number of hydrogens attached to each carbon equals the number of bonds it has, which is 4, minus the number of bonds we see. Now we can fill in the rest and see all the sticks for these molecules. But where are all the dots in these molecules and how do we find them? Well, the key to finding these dots is the fact that each atom of these molecules has a 0 formal charge. How do we know they have no charge? Because if there's no charge mentioned in our diagram, there's no +1 or -2 or such like that, or stuff like that, we assume that all the elements' charges are 0. The good news is that whenever carbon and hydrogen have 0 formal charges, which is basically always, neither of them will have any dots. It's just all sticks. So that just leaves us with oxygen, and we can actually use the fact that its formal charge is 0 to calculate the number of dots it has. Oxygen is in group 6, and each of these molecules, it has 2 sticks and a 0 formal charge. So it's going to have 4 dots in total. Here are the final Lewis structures for each of our molecules, all the sticks and all the dots. But if you remember the question of interest, it asks us to rank these molecules by the number of dots each one has. However, it's clear that we have a 3-way tie for this, because each of these molecules have 4 dots, 4 lone pairs.